Hello children, welcome to grade 6 mathematics lesson. Today we are going to discuss about the 14th lesson, that is types of numbers and number patterns, and this is the second part of the lesson. I am Himashi Gamage from Anand Balika Vidyalaya, Colombo 10, and today I am going to teach you this lesson. Before moving to the lesson, I want you to know what you're going to learn after studying this lesson. By studying this lesson, you will be able to identify odd numbers, even numbers, prime numbers, composite numbers, square numbers, and triangular numbers among the whole numbers, and identify number patterns formed by the above types of numbers. Right. First of all, we'll learn about prime numbers and composite numbers. For that, I'm going to take some numbers. First one is 3. So you can write 3 as a product of 1 into 3. So the factors of 3 are 1 and 3. Then let's get 4. You can write 4 as 1 multiplied by 4 or else 2 multiplied by 2. Therefore, there are 3 factors for 4. Those are 1, 2 and 4. Then let's consider about 5. 5 can be written as 1 multiplied by 5. Therefore, we have got 2 factors for 5. Those are 1 and 5. Next, we'll get 6. 6 can be written as 1 multiplied by 6 or else 2 multiplied by 3. Therefore, we can have 4 factors for 6. Those are 1, 2, 3 and 6. Right. Now, when you go through this table, you may have identified that for 2 numbers, they have got only 2 factors. For an example, 3, you have got only 2 factors, 1 and 3. That means the 2 factors are 1 and itself. Have a look at 5. Once again, it has got only 2 factors, 1 and 5. That means the 2 factors are 1 and itself. So, what is the difference here? We'll see. So, first of all, I'm going to introduce the word prime numbers. So, what are these prime numbers? So, in the previous table, we have noticed that 2 numbers got only 2 factors, that 3 and 5 got only 2 factors each. So, prime numbers in sense, if a number has got only 2 factors, then we can call that number as a prime number. So we'll move on to its definition. All numbers greater than 1, such as which have exactly 2 distinct factors, are called prime numbers. Right. That means I can get 3 and 5 under prime numbers. So what else? We'll get number 1. 1 has only 1 factor. Therefore, I can't get it under prime numbers. For prime numbers, I should have 2 factors. What about 2? Yes, 2 has 2 factors, 1 and 2. So 2 is also a prime number. Likewise, we can have 2, 3, 5, 7, 11, 13, and there are so many prime numbers. That means the only need is to be a prime number is it should have only 2 factors. If a number has only 2 factors, then that number is a prime number. Then we have to consider about composite numbers. Now, what are composite numbers? Previously, in our table, we saw some numbers with more than 2 factors. So, the numbers which consist of more than 2 factors are called composite numbers. So, first of all, we'll go for the definition. Whole numbers which have more than 2 distinct factors are called composite numbers. So, in our previous table, consider the number 4. We had 3 factors, 1, 2 and 4. So, it has more than 2 factors, therefore 4 is a composite number. Then consider the number 6. There we had 4 factors, 1, 2, 3 and 6. Therefore, once again it has got more than 2 factors, so we can call 6 as a composite number. Likewise, you can mention any number of composite numbers. There are so many. For an example, 4, 6, 8, 9, 12, 14, 15. Likewise, there are so many composite numbers to mention. Right. Now have a look at this table. There I have highlighted some numbers in yellow color, some numbers in white and only one number in blue color. So we'll see the difference. There, using white color, I have highlighted the prime numbers. So we can see 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Those are the prime numbers from 1 to 100. Right. Now what are these highlighted in yellow color? Those are composite numbers. That means the numbers which have more than 2 factors. Why have I colored number 1 in blue color? Number 1 has only one factor. It has got only one factor, means it does not belongs to prime numbers, no composite numbers. So 1 is neither a prime number nor a composite number, therefore there is no name. So that's why I have highlighted it in blue color. So if you are going to mention 1 under prime numbers or composite numbers, then it is wrong. So a number to become a prime number, there must be 2 factors, just 2 factors. And a number to become a composite number, there should be more than 2 factors. So 1 has got only one factor, therefore it's neither a prime nor a composite number. Right, now we are going to go for some questions. So to provide answers for these questions, you can use the table that I have shown you right now as well. Right, what is our first question? What is the only even prime number? Right, now here they are asking about a prime number and it should be an even number as well. So what is the only even prime number we went through? That is number 2. That is the only even prime number that we can go through. 2 has got only 2 factors, 1 and 2. Therefore, it's a prime number and it's an even number as well. Right. Question number 2. What is the smallest prime number? Now, We know that 1 is not a prime number nor a composite number. Then when it comes to 2, 2 is a prime number. It has got only 2 factors. Therefore, we can say the smallest prime number is 2. What is the smallest composite number? I told you 1 is not a prime number nor a composite number. 2 is a prime number. 3 once again has got only 2 factors. Therefore, 3 is also a prime number. When it comes to 4, 4 has got 3 factors. 1, 2 and 4. Therefore, 4 is a composite number. Therefore, the smallest composite number is 4. Right. Now we are going to discuss about square numbers. Now you already know what square numbers are because you have drawn square numbers when you were in grade 5 as well. Right. First of all, we'll draw some square numbers. Right. Now this is the smallest square number. There's only one dot here. So 1 row, 1 column, therefore 1 into 1 is 1. So 1 is the smallest square number. Then here comes, there are 2 columns and 2 rows. So altogether there we can see 4 dots. That means 2 into 2 is 4. 4 is our second square number. Here comes 3 rows and 3 columns. Therefore, 3 into 3, our third square number is 9. Likewise, there are 4 rows and 4 columns. So, 4 into 4, our fourth square number is 16. So, we can define square numbers as the number which can be obtained by multiplying a whole number by the same whole number. For an example, if we are going to multiply a whole number by itself, then we can obtain a square number. So if we multiply 1 by itself, that means 1 multiplied by 1, the answer is 1, that is our first square number. So if you multiply 2 by itself, then 2 into 2, that is 4, that is our second square number. Likewise, 3 into 3, that is 9, that is our third square number. 4 into 4, that is 16, it's our fourth square number. Right. Once again, we'll move on to a question. Now I told you that when you multiply a whole number by itself, we can obtain a square number. So when I multiply 1 by itself, we could get the first square number. Then when you multiply 2 by itself, you could get the second square number. So my first question is, what is the fifth square number? Therefore, to obtain the answer, I have to multiply 5 by itself. That means 5 multiplied by 5. My answer is 25. So, 25 is my fifth square number. Second question, what is the eighth square number? Likewise, I can multiply 8 by itself to obtain the eighth square number. So 8 multiplied by 8 is 64. Therefore, I can say 64 is the eighth square number. Right. Now have a look at this. Here I have got one dot. Now I'm going to produce it as a triangle. I'm going to add one more line to my triangle. I'm going to expand my triangle by adding one more line. Likewise, here Numbers that can be represented as above are called triangular numbers. That means if we can denote a number as a triangle, then those are called triangular numbers. So here I have mentioned the first 5 triangular numbers. For the first triangular number, we have got only one dot. That means 1 is our first triangular number. Next one is 3. Next one is 6. Next one is 10. And the fifth triangular number is 15. Right. Now next we'll see how to construct the triangular numbers easily. Now my first triangular number is 1. So for 1, I'm going to add 2. So 1 plus 2 is 3. That is my second triangular number. Then I have got 1 plus 2. For that I'm going to add 3. So 1 plus 2 plus 3. The answer is 6. So 6 is my third triangular number. Likewise, next I am going to add 4 for that. So 1 plus 2 plus 3 plus 4. The answer is 10. So 10 is my fourth triangular number. Last one, that means the fifth one. 1 plus 2 plus 3 plus 4 plus 5. So the answer is 15. So I can say 15 is the fifth triangular number. Likewise, you can continue so you can find triangular numbers easily. Isn't that so? So once again, I'm going to go for some questions related to triangular numbers. If the following sentences are correct, mark a tick, and if they are incorrect, mark a cross. Right, we'll go through the sentences. First one, smallest triangular number is 2. Is that correct? No, isn't that so? The smallest triangular number is 1, therefore this is wrong. Second one, a number is represented using dots that are arranged in a triangular formation. Then the bottom row consists of 6 dots. The total number of dots is 36. We'll see whether this is correct or incorrect. So, if the bottom row consists of 6 dots, that means we can easily find the triangular number, value of the triangular number by adding 1 plus 2 plus 3 plus 4 plus 5 plus 6. So, when you add all these together, you can get the value 21. So, here they have mentioned about the triangular number 21. But they have mentioned about the total number as 36. Therefore, that is wrong. So, this sentence is wrong. Question number 3. By adding two consecutive triangular numbers, we can obtain a square number as the answer. Here, two consecutive triangular numbers in sense, two triangular numbers which lies closer to each other. Right. So, we'll get an example. I'm going to consider about the third triangular number, that is 6, and the fourth triangular number. So, I'm going to add the third triangular number and the fourth triangular number together. I'm going to check whether I'm going to obtain a square number or not. So, the third triangular number is 6. The fourth triangular number is 10. So, now these are from my third triangular number and these brown color dots are from my fourth triangular number. Right. Now, when I combine those two together, I can see that I have obtained a square number. Actually, that is my fourth square number. Therefore, I can say by adding two consecutive triangular numbers, we can obtain a square number as the answer. So, this is correct. So, I have to put a tick. Next, we are going to discuss about number patterns. So, first of all, what are number patterns? Number patterns are actually a number sequence which is nicely arranged as a pattern. So, you can use square numbers and arrange it as a pattern, as a number sequence. Even numbers as a number patterns, odd numbers as a number patterns. Likewise, you can arrange the number sequence, therefore it becomes a pattern. So now here there's an example, we'll go through that. 1, 4, 9, 16 and continuous, these three dots represents for continuous, is the square number pattern starting from 1 written in ascending order. Find the 10th term of the number pattern. Right. Now how to find the 10th term? Since it's the square number pattern, we know that when you multiply 1 by itself, we can get the first number or the first term of the square number pattern. Likewise, when you multiply 10 by itself, then you can find the 10th term of the square number pattern. So, 10 multiplied by itself means 10 multiplied by 10, that is equals to 100. So, 100 is the 10th term of the square number pattern starting from 1. Question number 2. Which term is 36? This time they are asking us to find the number of the term. So we know that 36 is a square number. How to obtain 36? When you multiply 6 by itself, that means when you multiply 6 by 6, then you can obtain 36. Therefore, 36 should be the sixth term of the square number pattern starting from 1. Question number 3. Is 50 a term in this number pattern? We know that 50 is not a square number. Isn't that so? So, if we consider about the 7th term of the square number pattern, we know that is 7 into 7, 49. When we consider about the 8th term of the square number pattern, we know that 8 into 8, 64. So, in between 49 and 64, we have got no square numbers. Therefore, 50 cannot be a square number. That means 50 is not a term in this number pattern. So, we have to mention that it's not a term in the number pattern, in the square number pattern. Now, here comes the end of the lesson. Before wind up the lesson, I want to summarize the things that we have learned under the second part of our lesson. So, first of all, we have discussed about the prime numbers and composite numbers. There I have told you that if a number consists of only two factors, we call those numbers as prime numbers. And if a number consists of more than two factors, then we name those numbers as composite numbers. Then we have discussed about square numbers. There I have told you if you want to find a square number, you have to multiply the whole number by itself. For an example, if you want to find the fifth square number, you have to multiply 5 by itself. So 5 into 5 is 25. So 25 is the fifth square number. Then we have learnt about triangular numbers. There also I have mentioned that if you can denote a number using dots in a triangle, then those numbers are called triangular numbers. There also we have discussed on an easy way of finding the values of triangular numbers. For an example, if you want to find the third triangular number, you could easily find it by adding 1 plus 2 plus 3. So 1 plus 2 plus 3 is 6. Therefore, the third triangular number is 6. So that's all about types of numbers and number patterns for grade 6. I hope you got the lesson clearly, and then we'll meet up once again in another lesson. Thank you. Have a nice day.